Hi all. We've got another quick guide to go through. This one's going to be covering input managers. We're going to start this off by creating. We're going to be referencing our previous scene where we have main, core, and our two different managers. We're going to start this off by creating a new script. We're going to call this input manager. We're going to be using this to basically handle input registrations for different events that happen through our keybinds. First off, we're going to declare this as sealed. This way, as the reader, we know that this cannot be inherited from anything. We're going to be using a couple different, well, really just one function that exists through Godot. Our input manager is strictly going to be processing information, but we're going to be using a couple different events structures, but we're going to handle this through a couple different enumerations to describe to our input events what we're going to be handling. So for one, we're going to have a new enumeration type. This is going to be a keybind type, and this is essentially going to describe what our keys are going to be doing, and each one of these is going to be registered to a Godot inherit key. This is going to be something, and we're going to use this as a very simple example, but we're going to call this application quit. And we're going to bind this to Godot's escape key. And essentially what this is saying is that this keybind registers to application quit. With the escape, typically you're probably going to have this related to a maybe a close menu or something of the sort. But we're going to make this an application quit. So when we press escape, when we get to the end of this guide, this application will just terminate when we hit the escape key. But we're going to have a couple other enumerations. We have another one that's going to be key state type. This one's just going to be unsigned. The reason why this is a long is because the keys in Godot are bound to longs. They do not go from 0 to 255. They have different values, but there's only going to be 3 states for this. If you really want to, you can actually bind this to a byte. And these are essentially going to be only 3 states that a button could be held down for. So for example, we have press state, we have pressing state, and we have a release state. This represents the 3 states that a key could possibly be in. So say for example, we have our escape key bound to application quit. At the start of your application, it's probably in a release state. It's unlikely that someone's pressing that particular key. Secondly, pressed is going to be a per frame pressing. So I've pressed W this frame, so I want some event to happen, such as maybe if you're doing a first-person shooter, you might have the reload key bound to R or something of the sort, where you only want this action to happen once. And then there is the pressing state, where if I continue to hold this, I have some action that is happening for these. So we're going to take our keybind states, keybind types rather, and our key state types, and this is going to represent, we're going to keep a collection of these to represent the current state of our particular keybind. So for example, if we had a keybind, say walking equals key.w maybe, or I guess we'll call this move forward. And we're not going to bind these, but for the sake of examples, maybe we have a move backward equals key.s, strafe left is key.a, and strafe right is key.d. And for just a final key, we'll do key.r is our reload. We're going to space these out so we understand that this is all related to movement. This is probably our application information, and then this is actions related to maybe the player or something. And each of these is going to have a particular state. So maybe the reload is in a press state, maybe the strafe left is in a pressing state, maybe application state is probably in a release state. But we want to keep track of these so we have an understanding to react to different events. So we're going to create a new dictionary that relates to each one of these binds. We're not going to do any registering for the movements or strafing or reloads, but for the simplicity's sake, we will add these just for the understanding that these exist for all of them. So we have application quit. Each of these are going to probably start in a release state. I can't imagine having any one of these in a particular state that's not released on application launching. But it would get updated if you didn't set those to that. But for proper usage of these, you should probably set them to released. So we're going to move each one of these over. I like to keep things in alignment, so I'm going to move all these over so that I can quick edit these if I need to. So this is going to represent our initial keybind states. So every single keybind is going to be in a release state. And now we have our key state types. We have our keys, and we can just continuously append to these. I'm going to get rid of this. We're going to actually be using system.collections.generic. We're going to use the system dictionary in C# because we're actually also going to have a collection of read-only because we're not going to be appending to these dictionaries. We are going to do a new dictionary that also has a keybind type and an action associated with it. We're going to have 3 of these. These all relate to different events. So we're going to have a key pressed, keybind pressed, and we're also going to have 2 others that are going to be identical to each one of these. So we have a keybind pressing event and a keybind released event, if I could spell correctly. And each of these is going to be events that are going to be handled based off of the properties that exist, or the 3 different key state types that we have. So we're going to copy and paste each one of these. And we're only doing this out of simplicity, but each of these are actually going to be actions, and every single one of them is going to be null. We have no bound keys to this whatsoever yet, or bound events, actions, if you will, into each one of these keybinds. So each one of these is going to have its own keybind, so that this has an event for if the keybind has been pressed. This will be a keybind if, say move forward has a particular reaction to happen when the presses happen, maybe, or while we're still pressing it. Maybe reload, we only want to happen once, so we're going to do is keybind pressed. Like, for example, if we're holding W, because we're using WAST as our keybinds, WAST, if I'm still holding W after the initial frame press, maybe I probably want to continue moving. So we have move forward. That one will probably have an event bound for key pressing. Released, maybe you have an action that happens when on the up key. Maybe when you release W, stop, or release a move key, stop your player from moving. And pressed, if I hit application quit, which is what we're going to demonstrate, we're going to close out the application. And then finally, so each one of these we just have to add our new keybind. So if we add, jump equals key.space. If we add jump to this, we just have to add jump to each one of these. So now we have jump actions that are also associated with this. And lastly, we'll also have jump is released. So adding new keys into our registration is relatively simple. So now the important part is we're going to iterate over each keybind to determine if these keys are whatever state they may happen to be in. So we're going to check each keybind state that exists in our M keybind states. This is iterating over this because we're going to need to know our previous key state, or rather our current key state, as well as we're going to use the keybind type, which is actually going to be bound to the Godot keys. So we're actually going to be doing multiple things here. So we're going to retrieve the keybind type from keybind state. And that's going to be the key value. And this represents, so each one of these is bound to a key that exists in Godot. So what we can do is we can do bool is key pressed and use the Godot input to see if the physical key is pressed. And we can use this keybind type strictly by casting this to the key, which is bound to this. So when we retrieve application quit, it's actually looking for the key that escape is bound to. So this is W represents 87, escape is 4194305. This will be checking for the escape key, the space key, the R key, etc. So now we can check if this key has been pressed this frame. This represents is pressed this frame. And we'll key is pressed this frame. Was key pressed this frame? And this processes the Godot intrinsic function for nodes that updates each frame. So this would be for this particular frame when this is processing. Has this key been pressed? So we're going to also take the key state type that is bound to this. So we need to actually see what the current state of our keybind state, which is going to be the value. So keybind states is this collection of keybind types and keybind states. We want to see the keybind state that already exists for this particular keybind. And there's only three states that exist. So we either have pressed, pressing, or released. We're also going to just prefix this as shouldn't hit. Something went horribly wrong. Because in no case should we ever hit default. But I like keeping it in there just for the sake of being explicit, so I know that it's covered. But in no case should we ever hit that because there's only three potential key types. And so we have three separate states, key states that are possible. So we have pressed, pressing, and released. And this is the current state of what we have. So if the key is already pressed, that means we are still pressing this particular key, which means that we are going to call the isPressing function because we have not released this yet. Sorry, we're going to be calling the keybind pressing event because there is no way that we have not released this key yet. So we're going to be using the current keybind type, and we are going to set this to key state pressing. So we've pressed this frame. There's no way we could possibly release this. You can't go from press to release. There's always a frame where we're still pressing this because in no world are you going to be able to, within like one millisecond, are you going to be able to release this. So within the milliseconds, you will probably be pressing this again. So we've pressed this once. We're going to continue pressing this. And then we're going to call the keybind states sub keybind type. And we're going to put a question mark here and call invoke. Sorry, this is going to be the keybind pressing. So we're going to continue pressing this just for this particular frame. But what this is essentially doing is we are already in a press state, and so we are continuing to press this, and we're going to call the pressing event that's associated with this particular key. And we're going to move into a pressing state so that we can actually move into a release state afterwards. So we are going to call after we've already pressed, which on the first press will actually be within the release state, because what this is essentially doing is going from one state to the next state. So when we're in the press state, we're going into the pressing state. When we're in the pressing state, we're either going to continue pressing or move into the release state because we're no longer pressing it. Or if we're in the release state, we are going to move into the press state, which is the first frame of us pressing a key. So moving on to the is pressing state, this is where we're going to actually make use of our is key pressed. This is required because we have two separate things. If we are in the pressing state and the key is pressed, that means we are continuing to call this pressing event. So we can actually just duplicate this and continue calling the action that is associated with our keybind press. So if we were holding W, we would continue holding W and we would continue moving forward. Otherwise, if the key is no longer pressed and we're in the pressing state, that means we have now entered the release state. So what we can do here is just do keybind states sub keybind type. We are going to now update our state to actually use released. So our keybind state is now in a release state. So we were pressing this, a key is no longer pressed, so now we're going to invoke our release method. So now we can call, we've updated our state to be released. Now we can do released sub keybind type. And the question mark represents that this is a null event. The same thing is here. This is just shorthand that I don't have to do an if check. If this event has not been subscribed, skip over it. This just automatically checks whether the event has some action associated with it. You could have multiple actions, and each action is going to be called for invoke. And so if there are any any actions that have been bound to this particular key event, we are going to invoke every single one of those methods. So we are going to call released, and then we're going to invoke we're going to update that our state is for this particular keybind is now released, and we're going to invoke our release method, our released actions. Then we have our final key state type, which is released. That means we are already in a release state, which means we have not pressed any single buttons. So what we're going to do here is there's only one possibility that can happen, because if we are in a release state, you probably don't want to be calling. Maybe you might want to have an additional action that does something if you're always releasing, but typically you're probably not going to do that. So we're not going to cover that here, but if you really wanted to do something where a key is always released, maybe you have some action that is associated with that, you can take this one step further. It follows the same method. But in this particular case, if the key is released, we're just going to skip over all the keys and move onwards. Otherwise, if the key has been pressed, this is where we are going to swap to a press state. So we're going to take the exact same type, but now we're going to move into a pressed action. And then we have our keybind pressed sub keybind type, and continue to see if there's an action associated with it. And we're going to invoke the method, invoke the actions that are associated with this on the initial keybind. So in some cases, you may want to bind both the pressed and pressing actions on move forward and possibly even release. So say for example, move forward, you may have vector 3 move forward on the z-axis or something, where on the initial press, I want to move forward. On the initial press, I want to move forward. On the subsequent event, if I'm still holding it, I want to continue moving forward. And then maybe even on released, I actually call stop to stop my player from moving. Depending on, maybe you have acceleration or something like that, where you just want something to completely stop. So you may have 3 different binds, up to 3 different binds, or 4 if you happen to make the always active for releasing. Different states that you can handle for each event. So this actually covers all of the input manager, or setting up an input manager. So as you can see, it's very easy to add a new key state. You add, like we added jump, you just add it to each one of these, and now you can subscribe to this jump event. So as such, we're going to make a simple script here that is going to be just an application manager. And this application manager is going to be very, very simple. We are going to simply call application quit. And the only thing that this is going to do is we are going to retrieve the nodes. So we have a couple things to add here. Using our node directory, we have, I added these prior, but we have an application manager and an input manager. We need these same nodes that exist here. So we're going to add an application manager. I'm going to move that upwards because I like to keep alphabetical order. And an input manager. Sorry, this is just going to be a node. This is going to be an input manager. And we're going to drag and drop our 2 new scripts. So application manager is going to go on application manager, input manager, and for the simplicity of adding this to match, this is what we had prior. We are simply going to add an application manager. We're going to assign this 0u just because I like to keep things in order. And I typically, for enums like this, I just keep it in alphabetical order, strictly because it's easier to keep track of. But we're going to match our path, C core, so we can start referencing the input manager, and technically the application manager isn't actually used right now. But this input manager we are going to be referencing in the application manager. And so the input manager matches this directory here. And so this path right here, C core, actually goes from root to main to core, which is main core. Root represents the core scene, like the scene hierarchy. So this is where main falls into. All nodes are nested underneath root. So we start at main, core, and then we are now in the input manager, which is linked to this one. So input manager here is input manager. And so in our application manager, we are actually going to get our input manager. And we are going to do input manager by using, retrieving our input manager by calling get node input manager. And we are going to use the same node directory that we built, that we are referencing here, that we built in a previous video. I'll put a link down in the description. But this node directory is how we're going to retrieve this particular directory. How we're going to retrieve this particular node. We're going to call node paths, and we're going to have to pass in the node path. And to do so, we're going to do using node type, because this enumeration is tucked away inside this node directory, so we're going to reference it here by using node directory.node type. And the reason I tuck this away is so that it doesn't use anywhere else, and the reason why we're not doing node directory.type. We could just do node directory.node type input manager, but I don't like having multiple dot operators, so we're just going to use this, and we can get rid of this node directory. So this represents the node type, and this node is this node. So this is our input manager that is going to be found from our defined node directory. So now we have access to our input manager, and what we're going to do is simply bind a close event. So we're going to make a new method in our application manager that's simply called quit. Well, we're going to I like to name my functions appropriately, so we're going to name this as an action. So on application quit, and this is going to be a void method, no return value. On application quit pressed, to represent that this is an action that has to do with pressing the application quit button, we are going to do input manager dot key pressed plus equals, and sorry, this is going to be a key type, which also we need a new, to do the same thing as the node type, we're going to do keybind type equals input manager dot keybind type, so we don't have to do multiple dots. We're going to do keybind type dot application quit plus equals on application quit pressed. So now this has linked the input manager to what we have in our scene, so we now have the input manager that exists, and this is going to be on the ready. So this is on this is going to be subscribing to the event that happens when we press application quit, which is going to be processed per frame, and it's going to be on application keybind press. So this will no longer be null. This will add this function to this delegate to be processed when we happen to press this key. So when we press this, we are going to call, there is a Godot intrinsic, we're going to call this scene tree equals get tree. This is the scene that exists through Godot. This is a Godot method. You can find this in the Godot documentation. We're just going to call scene tree.quit. And this will simply close out our application soon as we hit, and I'm going to add sealed here because nothing is inheriting from this, and I like to be explicit. This will simply call scene tree quit when we have, well, technically on application quit, which is going to call scene tree quit, when we happen to press the application quit button, which is bound to escape. So if we run this application, so we'll save our scene. When we run this application, this is not going to have anything special on it. We're just going to press escape, and it closes out our application. If we happen to do anything more complex, such as instantiating things, maybe when you press W, it would move the character around. That's well outside the scope of this little tutorial here. But if you were to press W, you do the exact same thing. Maybe input manager dot keybind pressing sub keybind type dot move forward plus equals, and this is on our application manager, so this would not be, you would not want to do this here. You'd want to use it on like a character or something. But on move forward pressed, we would do on move forward pressed, and then subsequently, you know, maybe we have move backward, and we just copy and paste this. Then we do this, the same subsequent events. So every single one of these is going to be bound to the input manager, which we don't even need to maintain reference. And you could even do things such as input manager keybind pressed. So maybe you want to do something on the first frame of pressing move forward. So the first time you press W, plus equals on move forward pressed, and also this should be renamed to, well, this one will be renamed to pressing because this, it's always good to name your functions as they should be. So that one's pressing. We'll duplicate this one and call this one pressing. So now on move forward, we have actually two events. One is for the initial press, and then we have another one for the continuously pressing. And then maybe if you even wanted to, you could do a release call. Just depends on what you'd like to do. but I hope this helps. This is pretty much how you can easily maintain input management. And you can always, change the keybind types. If you really want to, you could actually assign these rather than through an enumeration. Give a variable that you could assign to these. So I hope this helps, and good luck in your Godot adventures. Cheers, dudes.